This is question 5 of 2019 Leaving Cert Honours Level. So here's A written here. It tells us that 3 plus 2i is a root of this equation. Now, a few things I'd like to point out. This is just a number. It's a complex number, yes, but it is just a number. Think of this question just like if they had asked 4 is a root of this quadratic equation. And again, this quadratic equation has z's in it. Think of that just like they were x's. Different letters don't really matter that much. In this case though, we do use z mostly when it's a complex number, and we mostly use x when it's a real number. But the letter shouldn't matter too much. Now the question wants us to find p and q. So they told us this is a root, which means when I put this number into z, I'll get 0 out. So let's go ahead and do that. We'll put 3 plus 2i everywhere we see a z. So 3 plus 2i squared plus p multiplied by 3 plus 2i plus q equals 0. Now we have one equation and two things we don't know. So that could be a problem, but we'll see how we'll solve that in a few moments. I'll just clean this up before we get to that point. Let's square this out. We get 3 squared is 9. We get 2i squared is 4i squared. 4i squared. We know what I squared is though. It's minus 1. That's the definition of I. And then let's see, we got 3 times 2i is 6i, and 2 times 3 is another 6i, so we get 12 i's. Plus 3 p's, plus 2 pi's, plus q is equal 0. Let's clean all this up, get all the real numbers. So p and q are real numbers, the question tells us that. So 3p is a real number. So let's get all them together. 9 minus 4, well that's 5. I think that they're the only full numbers, is it? Then plus 3p plus q. So these are all the real numbers. So these all add together to get a real number. And then let's put all the i's together. We have 12i plus 2pi. Well, let's take the i out and put them down like this. 12 plus 2p. 12 plus 2pi equals 0. Okay, here's the little trick then. We equate all the real numbers on the left with all the real numbers on the right. All the imaginary numbers on the left, all the imaginary numbers on the right. But there is no imaginary number on the right, so I'll just write 0i here. Because there's always 0i. Everywhere there's a 0i. Just, it's usually not useful to put it in. In this case it is. That means all the real numbers on the left, which is 5 plus 3p plus q, is equal all the real numbers on the right, which is 0. Real numbers on the left is 12 plus 2p. Real numbers on the right is 0. And you can leave I here if you want in front of everything, but they would just divide everything by I and it would be gone again. Now the second equation is nice and easy to solve. We just get 2p is equal minus 12. We get p is equal minus 6. Use this in this equation to find q. We get 5 plus 3 minus 6's plus q is equal 0. Let's clean this up. We get a minus 18. 5 plus minus 18 is minus 13 plus q is equal 0. So q is equal 13. That's our final answer. I like to put a little square around, let the examiner know where it is. Or write it again. Lots of students, better neater students than me, write it again. P is equal minus 6 and Q is equal 13. On to part B. It's a two-part question. There's part 1 and part 2. We'll just do part 1 first because we might run out of room. It asks us to write V here. V is equal 2 minus 2 square root 3i in the form of V is equal to or, it doesn't write V equal, sorry, it just says in the form of or cosine theta plus I sine theta. Write in this form. Now this is a very famous form. We use it for the Pythagoras Theorem, but it's just another way to write complex numbers. It's really just another way to draw things as well. We can see it as. So I like to draw a little picture here, because that's what I like to do. Writing it this way can get us to the picture. Writing it this way can also get us to the picture. So what I like to do is I like to go from here to a picture, back to here. And vice versa if we want to do it the other way. So every point, I mean, on a, like this looks like an XY, it's a real imaginary graph, but a two-dimensional plane, any 2 points, any 1 point can be got with 2 pieces of information. Now, in the first form, the way we're used to real, imaginary. Real, imaginary. We just go number of real, 2. Number of the imaginary, minus 2 square root 3, which is, we can look at a calculator, what is that? That's probably like 3 point something down here somewhere. And that will get us to a point. That's one way to find any point. Another way is using polar coordinates, which is what these are. And that uses an angle, here's an angle here, and a length. So we use the angle, and we just decide where to go. Here's 0, here's 90 degrees, here's 180. Or I'm sorry, this question asks us to use radians. Just the same. Instead of using 0 to 360, we use 0 to to 2 pi. So we go, here's 0, here's a half pi, here's 1 pi, here's 3 halves pi, and down here will be some number for an angle that goes all the way from here to here. Let me put a line in here. So this angle, this is really the angle I want. And that's this angle. That's how we draw a point. And we need one more thing. We need a length from here to here, which will be r, this number here. So if we can draw this picture using these numbers, we can get this information back out of it. Now let me just rub this out and draw it again without a lot of these lines. So a line here, and I'll put this point in again. We have a point here. So I really just want to play around with this triangle. Let's have a look what we know. We know this is 2. So we know this length here is 2. We know this is minus 2 square root 3. So we know this height is 2 square root 3. There's no minus in heights. And that's it. That's what we know about this triangle. So let's draw this triangle one more time. Let's put it here. And we got 2 square root 3. Really, I'd love to find this angle here. Let's call it A for the moment, because theta is this big angle, remember. But don't worry, if we find this small one, we should be able to get the big one with no trouble. Just take it away from 2 pi, or 360 degrees if you're using that way. Okay, so what do I need to know? I need to know this length, and I need to know this angle. So we just go back to our trigonometry. We have a few different things. So if we have an angle, we have the opposite and the adjacent. So which formula helps with that? Well, it's the tangent of A in this case is equal to 2 square root 3, the opposite, divided by the adjacent. So that means the tangent of A is equal to square root 3. Now we could go ahead and put this in a calculator. A is equal to the inverse of the inverse tan of square root 3. And that will give us out a number. We can also just notice this is a famous one. And lots of, in the Irish system at least, which I assume a lot of you are if you're looking at this video, your table book will give you a formula for all the simple angles, 30 degrees, 60 degrees, 90 degrees, and so on. And this one is there. Tan of an angle is equal to 3. And that angle is pi over 3. So A is equal pi over 3, otherwise known as 60 degrees. But again, they asked us to use radians. Let's use radians. So let's change this out here. This is pi divided by 3. The only thing now I need is r. R is equal, it's Pythagoras Theorem, so r is equal to 2 squared plus 2 square root 3 squared, square root of it. Let's clean this up, just take a few lines. The calculator will do it straight away, but it's good practice to do it yourself. 2 squared is 4, square root of 3 squared is 3. So that is 4 plus 12, which is equal to square root of 16, which is equal to 4. So this radius here is 4. This radius here is 4. This angle here is pi over 3. So what is the entire angle? One last little sum. we'll get 2 pi minus pi over 3. So many students are terrible at doing simple fractions. Use a calculator, ask it out, ask the calculator to do it for you. But just how I just do it nice and simply, I just put a 3 and a 3. And now I have the equal terms. We get 6 pi minus 1 pi over 3, which is equal 5 pi over 3. Okay, so there are all of the numbers we need. Do not leave your answer like that. Tell them your answer is phi is equal to, or is 4, and times cosine of the angle. Well, the angle is 5 pi over 3. Plus I'm sorry, this should be over 6, should it? No, over 3. Okay, I sine 5 pi over 3. That's it. That's our final answer for B part 1. Let me rub this out and we'll do part 2. So here's B part 2. They ask us to use our answer from the first part. This is V equals this. And they ask us to find W. Now W, they say, W squared is equal to V. Ask us to find the 2 possible answers. And we would expect 2 answers when it's squared. So that should be easy. It's just W is equal to square root of V plus or minus. Again, we'd write that as plus or minus phi to the power of a half. And again, this should be easy using the Pythagoras Theorem. Let me quickly write the Pythagoras Theorem. Let me write it over here. It tells us that if we have something that looks like this, so or multiplied by cosine theta plus I sine theta, and if all of that is to a power, any power, n doesn't have to be a even number, it could be a half, for example. That tells us the answer is just or to the power of, sorry, not half, to n. It will be a half in this question. Or to the power of n cosine n theta plus I sine n theta. Let me put a little brackets around this to make it less confusing. So that's as simple that way. So this would actually be really easy to do. Let me stand here. Square root of v is actually just 2 cosine 2 times this. I'm sorry, half of times this, which is 5 over 6 pi, plus I sine 5 over 6 pi. There, I've done plus or minus out front. I've already done the question. Except for one thing, they didn't want the answer to look like this or to look like this. We're going to get it to look like this first of all. They would like the answer to look like, let me see what it says. A plus IB. The classic way. A and B are just real numbers. But first let me do it the only way we can, because that's difficult. To get the square root of a complex number is very difficult without doing this. So let's go ahead and use this. Do it this way first. Let's find the square root of v. So phi to the power of a half is equal, like I said, it's 4 to the power of a half. I'm just using this formula here. Cosine, I already set out what I'm doing. A half 5 pi over 3 plus I sine, a half 5 pi over 3. Now let me clean this up. This is 2 cosine, this is 5 over 6 pi plus I sine 5 over 6 pi. And plus, yeah, we don't need a plus or minus. I'm just saying the square root of a half. I'll put the plus or minus back in when we get W. So really, this is the answer, and this could be the answer with a plus or minus, but they don't want it that way. They want it the other way. So once again, just like in part 1, we're going to go ahead and use a picture. This time they've told us this way, and we're going to get back the other way. So let's see what this picture tells us. It tells us to go to this angle, 5, 6 pi. Pi is here, so that's too far. So 5, 6 pi looks something like this. This angle here. So not everyone goes both sides this direction. Some people just go all the way up and they do this question twice. I'm going to show you why. Because then it asks us to get 2. Well, let me write in here W equals this, plus or minus. Let me put the plus or minus in. So let's go 2 out here. So this is 2. And let's go minus 2. How do you go minus 2 that way? Well, you go backwards. You go out here. So here's the 2 answers. Here's the 2 answers. These 2 answers, this is what they look like. And what the question wants is to find the classic way. The real number there, the imaginary number here. That's what the A and B is. I rubbed it out there. Let's see, A plus IB. There's A, and there's, well, here's yeah, this is A, this is minus B, this is well, that's minus A. I guess there's two different answers, so that's going to be a bit confusing with the signs. Let me rub that back out. But anyway, we're looking for these two, this number here, this number, which will be the same as this number, plus and minus. This will be the same here, this will be plus, this will be minus, because they're the same triangles. So let me take this triangle out. Let's take this one over here. This triangle here. Well, let's make that a good bit bigger. Let's go here. Now, what is this angle here? We know this is 2. We just need this angle. 5 over 6 pi is this whole way. So we just get pi minus this. So this angle here is pi minus 5 over 6, which is just 1 over 6 pi. So all we need to do is get this length and this length. That is, let me rub this out up here, gives a bit more room. So these two lengths are just using trigonometry. So we will use the sine rule. Sine of an angle is the opposite over the hypotenuse. Let's write that one down. Sine pi over 6 is equal, let's put an x in, and maybe a y, we're going to find this, is equal to x over 2. Let's solve for x. X is equal to sine pi over 6. We can put this in a calculator, but first let's find y, and I'll do them both at the same time. So sine, oh sorry, not sine. To find y, we need cosine of the adjacent over the hypotenuse. So cosine of the adjacent, cosine of this angle is equal the adjacent, which is y, over the hypotenuse, which is 2. So again, solve for y. Y is equal to 2 cosine pi over 6. If you're going to do engineering or any physics, you're going to use these a lot. We learn to get the heights and the lengths of loads of things. You're going to get very used to just putting the number in front of cosine, and you're also going to be using polar coordinates and Euclidean geometry as well, and going in between them. So this should become very common to you. Okay, let me grab a calculator and we'll get these two numbers. Now, you don't necessarily need a calculator. Again, in Ireland, you'll have your formula book. This is a very simple, this is a very normal equation to do. This is just 30 degrees, by the way. So sine of 30 degrees, 2 times sine of 30 degrees. We could check on a calculator, but it should equal 1 or a half, 2 times a half. So we just put it in, 2 sine, where's pi? Pi divided by 6 is equal to 1. And this one here, again, it's not as famous. You might have to look it up, but it's easy enough to do. I think it's square root of 3 over 2, 2 times it. So let me put this in. 2 cosine pi divided by 6 is indeed equal to square root of 3. Okay, so that's mostly it. Although we don't really have an answer, we have a picture and we have all the numbers we need. I know the length here is square root of 3. This length here is square root of 3. That must be square root of 3 then. This must be minus square root of 3. This height here is 1. This must be minus 1 down here. This must be plus 1 up here. We can get these 2 points here in the Argon diagram. So let's go ahead and do this. This point here from an Argon diagram is minus square root of 3. So let's write this as W equals minus square root of 3, and then the complex one is 1, so plus 1i, or just I. And the other answer, the other W, is this point here. That is plus square root of 3, or just square root of 3. And then minus 1i, or just minus I. There are the 2 answers, just getting from the picture. So part B part 1, B part 2 was just moving between the polar coordinates really. In between they ask you to get the square root. They very often ask you to get something to the power, so you need to use the Pythagoras Theorem. Right, thank you for watching. If you have any questions, put them below. I'll do my best to answer everything. And I'll see you next time where we'll do obviously question 6.